You found the video tutorial for pages 4 and 5 in our Unit 2 homework packet. So let's take a look at it. We're looking at number 1. It says this orbital notation correctly represents valence electrons of group blank. Okay, so I could show this as Lewis dot structure, and I bet you'd get this question right. So what I'm showing you here is the first 2 electrons have to share an orbital, have to share a bedroom. And then I've got my up arrows, 1, 2, 3, and then this one's sharing there. So if I said this Lewis dot structure correctly represents what group, you would count 1, 2, 3, 4, 5, 6 dots means group 16 or 6A, which is the same thing we're showing you here. This is the first bedroom, then 3, 4, like that, 2, 3, 4. So the S and P orbitals represent our valence electrons. So then trying to reverse that on number 3, it says complete the orbital notation for valence electrons of group 14 or 4A. First thing you need to know is how many valence electrons does 14 or 4A have? And that answer is 4, whatever the number in front of A is. So if I was doing the Lewis dot structure for this, I'd say mom and dad share the first bedroom. Okay, the first 2 dots go together. Then 3 and 4, the kids want their own side. So they have to share that first bedroom because the first bedroom is an s orbital. 1 and 2 go together, and then 3 and 4 are going to get their own bedroom, their own p orbital, like that. List the following elements in order of increasing electronegativity. Your best bet for this, and I actually need to rip up some paper myself, is to rip up little pieces of paper to find your elements. Okay? On test day, I find teeny scraps of paper all over my room, and I'm just fine with that. Okay? So sulfur, I'm going to say sulfur is right here. I'm going to mark it. Oxygen, okay, neon, and aluminum. I have people rip up little corners of their tests, and I just give them a thumbs up. Good job. Smart. Okay? So sulfur, oxygen, neon, aluminum. So it says increasing electronegativity. I'm going to find my electronegativity arrows, and I see they're pointing at fluorine for the biggest. So the first thing I notice is neon isn't on the board. Okay, it's out of bounds. These are the ones we talk about electronegativity for. Noble gases have no electronegativity. So neon is going to be least electronegative. Neon. Okay, we're going increasing, so low to high. And then we're going to say, okay, after neon, that one doesn't count. This one's furthest away. So that one is aluminum. And then here, these guys are equally this way, but it says increases here next, so sulfur, and then the highest would be oxygen, because it's closest to fluorine. Fluorine has the highest electronegativity, like that. Okay. Talking about electronegativity again at number 8, it says, does it increase or decrease as you move down a group or family on the periodic table? Okay. My arrows are pointing up. The biggest electronegativity is this way. So as I move down a group, it's less electronegative. That means it decreases. So you can either circle decrease or go like this. Okay. As you move down a group or family, it's less electronegative. Let me pause this real quick. All right, I apologize. You caught me making a video during morning announcements. Okay, back at it. Number 10 I want to look at with you. It says list each of the following sets of atoms in order from smallest to largest atomic radius. Okay, guys. This is the less than symbol, right? If you guys remember from elementary school, the alligator eats the bigger number. Okay, so we're looking at biggest over here. That's what the alligator's trying to eat. And then this would be small. I cannot tell you. At least 30% of students will get that backwards on the test because they think this is the greater than. Just okay? Smallest to biggest. Okay? So looking at for atomic radius is pointing this way. So big fat francium is the biggest radius on our periodic table. So the closest you are to big fat francium, the bigger you are. So I'm going to maybe try and do like that, if that works. Okay? Kind of. Lithium, That's not going to work. I'll fix it. Lithium, let's see, fluorine's way over here, and carbon. Okay, I'll switch it like this. You guys will see I did this. Okay, so the closer you are, lithium, carbon, and, sorry, fluorine. There's my other one. Closest you are to big fat francium, the bigger your atomic radius. So I can ignore this arrow right here because they're all equally, they're in the same period. But we'd say this way, as you move this direction, you're getting bigger. So I would say smallest radius, bigger radius, biggest radius. So that's fluorine smallest, carbon next, and lithium the largest. So fluorine smallest, carbon next, and lithium the largest. Now the reason for that, which you do need to know on the next page, is we have the same number of energy levels here. They're all in period 2, but fluorine has way more protons in its nucleus, so it's able to pull those valence electrons in closer, because there's more positives to make it tight. Okay? And then number 12. Number 12 says, circle the word that completes the sentence. Compared to the atomic radius of iodine, the atomic radius of fluorine is because, which we just kind of answered. Let's look. Compared to the atomic radius of iodine, which is here, the atomic radius of fluorine is. Let's get this all the way on the screen. We're talking about iodine and fluorine. Compared to iodine, fluorine would be smaller because it's further away from big fat francium. It says atomic radius increases as you move down, so fluorine would be smaller than iodine. So that's the first answer. Compared to iodine, fluorine is smaller because iodine has more protons or more energy levels. Okay, iodine has more protons and more energy levels. That's true. They're both true. Really, when we're comparing things in the same group, or excuse me, the same period, we're more concerned about their protons. But when we're comparing elements in different periods, we're comparing their energy levels. Fluorine has 2 energy levels in the second period. Iodine would have 3, 4, 5 energy levels drawn around it. Its Bohr model would be much bigger. So primarily, because it has more energy levels. Now technically, iodine also has more protons, so that's not a wrong answer per se. It's just not as good of an answer. Okay, so if you were confused, I understand your confusion on that question. 15 and 16 are super important. They're harder questions. These ones aren't too bad. Which one is more electronegative? You'd say oxygen because the arrow points this way. Okay, why is it more electronegative? That's a harder question. It's also a more important question. So 15 says, as you move across a period that way on a periodic table, protons are added to the nucleus, and elements are able to pull their valence electrons in closer to the nucleus, giving it a smaller. Okay, so let's just draw a little diagram for you. Here is the nucleus. I'm going to label that as N for nucleus. And here are the valence electrons. We're going to label that VE for valence electrons. Okay. The distance between it, between the middle of a circle and the outside of a circle, is known as the radius in geometry. So if we're talking about the distance between valence electrons, the outside, and nucleus, the middle, we're talking about atomic radius, A. It's measured by the atomic radius. Number 16 says noble gases already have a full octet of valence electrons, so they do not attract additional electrons, giving them very low. So this didn't talk about distance between valence electrons and nucleus. So I can confidently say that's not about atomic radius. Kind of the big hint I gave my students in class is that ionization energy is about its electrons, an atom's own electrons. This problem is talking about additional electrons or extra electrons. Extra, E-X-T, I forgot the letter R-A. There we go. I can't spell and talk at the same time. I really can't. Additional or extra electrons. So noble gases have the lowest electronegativity. And if you look here, they have very high ionization energy. Helium's the highest ionization energy. But in class, we taught you that noble gases have no electronegativity. They do not want extra electrons. Number 19 is a little bit easier because you're just using that backside of the periodic table. It says circle the atom in each pair that has the greater electronegativity. So I've got A, B, and C, 3 different problems here. If I scoot that all the way up, we can say gallium or calcium. Let's see, gallium's here, calcium's here. So which one would have more electronegativity? My electronegativity arrow points that way. So more electronegativity would be gallium. Let's circle that, gallium. On B, lithium or oxygen. Well, oxygen's right next to fluorine, which is the highest electronegativity. So this way, oxygen would have the greater electronegativity. And then sulfur or chlorine, those are both very electronegative. But which one's greater? It's actually kind of hard to... According to this periodic table, let's just say that. We'll say this way. So further to this side would be chlorine, would be greater. Okay. Number 19. An atom which easily loses its electrons in a bond has low ionization energy. We're talking about its attraction to its electrons. So ionization energy. An atom which strongly attracts electrons in a bond has high. Attracts its electrons? No. Attracts electrons in a bond, those would be extra electrons, E-X-T-R-A this time. So extra electrons is measured by electronegativity. N-E-G-A-T-B-I-T-Y. Gosh darn it. Okay. These can be hard to tell apart. Okay, these 3. So make flashcards if you need to. Distance between the nucleus and valence electrons is your radius, atomic radius. Attraction to an atom's own electrons, its electrons. Attracting additional electrons or extra electrons or bonds, electrons in a bond would be electronegativity. And then number 22, I gave you an example of a 2-sentence answer. It says explain why neon has higher ionization energy than chlorine. They both have very high ionization energies. But ionization energy, IE, means how attracted is it to its own electrons. So I said neon has a full octet of 8 electrons. Since it's full, comma, it is very attracted to its electrons and won't lose them easily. Right? If I come to a noble gas and I say, hey, can I have one of your electrons? I'm like, no, I'm perfect. Why would I give you any electrons? No. If I come to these guys and I say, hey, can I have one of your electrons? They're like, yes, please. We only have one anyways. Take it away from us. So they have low ionization energy. They don't want to keep its electron. These guys will never give you its electron. It takes a lot more energy. Okay. Try and get a good 2 sentences for these other ones. Check your notes. We talked about them in class. If you were absent, check Canvas. The notes are on Canvas. Thanks, y'all.